Okay, let's dive right into this. Welcome back to The Explainer. Look, we need to talk about a classic scenario from the Cambridge Physics past papers, code 0625 if you're keeping track. You've probably seen it 100 times, an electric motor lifting a heavy load, and you're asked to calculate or explain the power. Now, a lot of students see that word, power, and immediately think, yes, guaranteed easy marks. But, well, the examiner reports tell a completely different story. It's actually a bit of a disaster zone. So many students lose crucial points right here, and honestly, they end up barely missing the next grade bounder just because of this one topic. So today, we're taking a completely different approach. We're going to treat this explainer like an archaeological dig. We're going to unearth exactly what examiners are actually looking for, hidden just beneath the surface of the question. Layer by layer, we'll uncover the perfect answer. So you really have to ask yourself, why do otherwise brilliant students consistently find evaluating evidence and drawing conclusions about power so challenging? To understand this, let's look at two very typical approaches we see in the exam data. We'll call them Alex and Sam. Now, Alex is what we call an over-explainer. Alex sees the word power and just completely overloads the response with raw physics facts. We're talking paragraphs defining work, defining joules, writing out the entire history of energy transfer. But there is zero analytical depth. There's no application to the specific scenario in front of them. Then, on the flip side, you have Sam. Sam is the rusher. Sam completely misses the command word requirements, quickly punches some numbers into a calculator, and just jots down 500 watts with absolutely zero working out. You can probably guess what happens next. Both of these approaches totally miss the mark. You see the red pen all over their papers. Why? Because they lack a systematic approach to decoding what the examiner is actually asking for. All right, so how do we fix this? We're going to dig through this systematically. First, we'll decode the core concepts of power, so we're all on the same page. Then we'll walk through the procedural framework, the actual steps you need to take. After that, I'm going to share something huge, the method mark strategy, which is basically an insider secret. We'll also cover the top 3 hidden traps that examiners warn us about every single year. And finally, we'll unlock the real treasure, evaluative thinking skills. Let's start right at the surface level. We have to decode these power concepts before we can dig any deeper. Now, on the surface, the concept of power seems incredibly simple, right? It's literally just the rate at which work is done or the rate at which energy is transferred. Mathematically, we define it as P equals W over T, or P equals delta E over T. So if we go back to that motor lifting a mass, you simply calculate the work done against gravity and divide it by the time it took. That is the strict academic baseline. You have to know that. But here's the catch. Just memorizing the formula, exactly like our friend Alex did, is not enough. The Cambridge assessment framework demands so much more than just reciting an equation from memory. You need to show that you actually understand what those letters represent in the real world. Because here's the reality. The marking scheme heavily prioritizes deep, analytical understanding over superficial breadth. The assessment is explicitly targeting different cognitive domains. They want to see your knowledge, sure, but they also want application, and they desperately want analysis. To achieve this kind of analytical depth, the absolute top-scoring candidates structure their answers using something called the PEAL framework. That stands for Point, Evidence, Explanation, Link. You make your central point, you provide evidence extracted directly from the given data, you explain the underlying physics principles, and then, and this is crucial, you clearly link it back to the specific context of the question. A winning answer doesn't just randomly state the power formula. It explains the exact rate of energy transfer precisely in the context of the specific scenario you're analyzing. Now, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, moving on. Let's get our hands dirty. It's time for the excavation phase, where we actually apply a procedural framework. You need a standardized, foolproof approach to process complex physics problems without panicking. Think of this as your survival guide. Step 1. Identify the key elements. Scan the text, look at the graphs or data tables, and pull out exactly what you need, usually energy and time. Step 2. Apply the relevant principles. This is where you establish your baseline formulas based on what you found in Step 1. Step 3. Execute the analysis with crystal clear working. Please listen to me on this one. Do not just write down a final number. Show your substitution. Show the examiner exactly how your brain is working. Step 4. Verify your results. Take a breath and look at your answer. Does it logically make sense for a tiny toy car to have a power output of 1,000,000 watts? Probably not. Catch your own mistakes. And finally, Step 5. Present it in the appropriate format. Use proper headings, the correct terminology, and the right units. Applying this exact 5-step sequence is what turns a chaotic, rushed answer into a beautifully structured, multi-mark masterpiece. All right, now we're getting to the good stuff, the insider secrets. Let's talk about the method mark strategy. If you take nothing else away from this explainer, remember this crucial insight. Marks are awarded for the procedure, not just the final answer. Examiners are actively looking to reward your systematic process. If you correctly identify that power equals work done per unit time, and you physically write down the right numbers plugged into that equation, you secure method marks. Even if you have a total calculator fail and your final result is completely wrong, you still get points. When you're staring at a complex data table comparing different machines, you aren't just looking for the machine with the biggest energy number. You're looking for the highest rate of energy transfer. Showing that division process, writing it out on the page, is what secures the points. The final answer is great, but the process itself is king. But even with the right process, there are traps. Let's uncover the top 3 examiner warnings. And hey, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @AceTheExams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's look at the red flags. The principal examiner reports highlight 3 specific traps that catch students year after year after year. First trap, answers are often way too vague. Writing "the machine is fast" is descriptive, it's everyday language, it is not analytical physics. You will lose marks. Second trap, students totally forget to check format and presentation conventions. For example, leaving your answer in watts when the command explicitly requested kilowatts. It's a heartbreaking way to lose a mark. And the third trap, which is honestly the biggest one of all, answers are not specific to the context given. Writing out a generic sentence like, "Power is energy over time, it increased because energy went up," just shows you memorized a flashcard. It loses marks because it fails to define what energy or which specific machine from the question is actually being discussed. I want to read this stark warning directly from the source material. It says, "The classic mistake is providing generic answers, not specific to the question context. Always link every point to the given scenario." They're practically begging you to do this. This lack of contextual application is literally the dividing line between average responses and top-tier A-star responses. If the scenario involves a wind turbine generating electrical power, your explanation must specifically mention the wind's kinetic energy transferring to electrical energy per second. If you just give generic physics definitions, your score will be capped. You have to take your knowledge and apply it directly, forcefully, to the specific scenario they handed you. Which brings us to the deepest layer of our dig. The absolute treasure, evaluative thinking skills. There is a massive, fundamental contrast between a basic descriptive answer and a high-level evaluative answer. A descriptive answer simply states what happens on the surface. It says, "Machine A took 10 seconds to do 1,000 joules of work." Okay, true, but basic. High-level evaluative thinking actually questions the assumptions and considers different perspectives. An evaluative answer would look at that same data and point out that while machine A has a theoretical power of 100 watts, this assumes perfect efficiency. It points out that the theoretical calculation ignores energy dissipated as heat due to friction, which means the actual useful power output will be less. Do you see the difference? This level of thinking questions the evidence instead of just blindly repeating it. That is how you get maximum marks. To master this, you need to understand that the cognitive framework for these exams operates on exactly 3 levels: descriptive, analytical, and evaluative. And to conquer all 3, you need to follow 3 core rules. Rule 1, command word decoding. You must always know if the question is asking you to simply describe or if it's asking you to evaluate. Rule 2, Peel framework application. Always use point, evidence, explanation, link to structure your points with bulletproof logic. And Rule 3, the time management matrix. Please avoid spending 10 minutes writing a novel for a 2-mark descriptive question, and conversely, do not rush through a 5-mark evaluative question. Those higher-order questions demand time, they demand that you compare approaches, and provide justified, thought-out recommendations. When you are operating at that highest evaluative level, it requires identifying both similarities and differences. And the secret weapon here is using comparative connectives, words like whereas, however, and in contrast. True comparative analysis means supporting every single point with mathematical evidence, pulled straight from the data. and evaluating alternative interpretations. For example, if two heaters have the exact same power rating, what's the nuance? You have to dig for it. Maybe one reaches its operating temperature faster. Exploring these tiny nuances, identifying limitations in the data they gave you, and noting assumptions, like mentioning that the calculation ignores air resistance, that is what demonstrates complete, undeniable mastery of the concept. So let's wrap this up and recap the core takeaways from our dig. We have uncovered a complete step-by-step answering system for power questions that forces you to prioritize analytical depth. To guarantee you retain and actually apply this framework, you need to do 3 things on your next practice paper. First, actively decode the specific command words before you write a single letter. Second, rigorously apply the PL framework to logically structure your points. And third, ensure your answers are tied strictly to the specific context provided, aiming for that evaluative thinking that questions the underlying assumptions in the data. Doing this will completely transform your mark scheme potential from 0 to 100%. So, here is my final question to you. The next time you sit down and face a complex, high-mark problem on power, will you dig for analytical depth or will you fall for superficial breadth? The choice is entirely yours. Apply this archaeological dig strategy. Show every step with your workings, rigorously evaluate the context, and you will completely master the challenge. Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.